Hey, Lacey. We did section 3-2, the first half yesterday. We're going to do the second half today and call it a day. Homework assignment for this section. You guys also. Here's the homework section. It's also written on the board, but additional instructions for 28 through 40. It has some weird symbols in there where it says use the limit definition to find blah, blah, blah. Just find the limit. Don't actually use the limit definition to do that. I want you to graph it, find the limit, or use a table, whichever one you want to do. Just find the limit. Don't actually do the definition part of it. There you go. That's your instructions. Okay? So, we are on example 3. But before we do that, let's go back and kind of look at example 2. When you're looking at graphs, okay, you guys can graph these with Desmos, you can graph them with a graphing calculator, you can graph them by using a table, I don't care. What you're doing is you are looking and you're trying to find the place, or you're trying to find the y coordinate at the certain value that it gives to you. So when it says like the limit of this guy right here, as x goes towards 0, it's saying if the x coordinate is 0, what would the y coordinate be? Okay, so another way of looking at this is, I'm looking here and this graph looks like that. Wynn, can you mute yourself? Or something?
Yes,
Oh.
it does.
Okay, so here's the graph. The x coordinate of 0, I'm trying to find where the y coordinate is at. This is the point 0 comma something, and I'm trying to find what that something is. Okay? So,
sorry, I was choking on ice.
Alright, so one way of doing this, you guys gotta be quiet. One way of doing this, if I'm looking for the x coordinate of 0 and I'm trying to search for the y coordinate, look at the graph and find as he's coming in on the left side and as he's coming in on the right side, or vice versa. What is that y coordinate approaching? Okay, this is the coordinate point 0 comma 2. So the limit is 2. It's approaching a y coordinate of 2, right? Okay, go down to this one. Wynn, mute yourself.
I'm not even doing anything.
I know, but you can hear it, and I don't want it to be on the recording because Lacey's not going to hear anything but you.
Oh,
Mute yourself.
She's not on
Thank
Zoom,
you.
She's just recording.
I'm recording.
Why doesn't she just get on Zoom?
I don't know.
She's at a doctor's.
Because she's sick or a doctor's or something. I don't know. Okay, so this coordinate right here, if we're trying to find the limit at this point, listen, watch the graph. Watch the graph. At this point, coming in from the right and coming in from the left, what is the y coordinate at this point? I think it's like at 1 or something. So the limit is 1 at that point because coming in from the left and in from the right, the y coordinate is at 1. Okay? Looking at this guy now, this is where limits fail to exist. Okay? The limit does not exist like on Mean Girls. I'll pull it up here at the end of class if we have time. Okay? So here's what's happening. They have this function right here. They are asking us to find this thing, the limit as x goes towards 0. Okay? What I want to do is this function right here, I would like to try to plug 0 into that function. But if I plug 0 in, I will end up with something that looks like this. And what's the problem with this thing?
You
Can't divide by 0. So that's why he poops out there, all right? So if I graph this thing, here's what he looks like. He looks kind of funny. He does this on the one side, and he does this on the other side, okay? That's what the graph looks like. So he's touching here, and he's touching here, and he's coming in from the left and the right side, and he looks like that, okay? So what I do is I look for the limit as it's approaching 0, so the x coordinate of 0. And looking from the right side on this graph, as I'm coming in from the right side, it's approaching a coordinate of 1, right? A y coordinate of 1.
I have a question.
And he's coming in from the left side, he's approaching a y coordinate of -1. What's your question?
I can't see the notes.
Oh, Lord, child.
Maybe you shouldn't be so.
Where am I at here?
Brooklyn, shut the fuck up.
Hey,
I'm Lacey, actually.
Brooklyn's not here today.
Yeah, Brooklyn's the one who's. We're recording for Brooklyn, actually.
All right.
Lacey's gonna be so confused.
Yeah, Lacey's getting kind of confused.
Why are you confusing me?
All right, here we go. So, coming in from the left side, coming in from the right side. The right side coming in to that point where x is 0. He's approaching a y coordinate of 1. He's approaching a y coordinate of -1. Because those are not approaching the same y coordinate, this is why the limit does not exist. So we would say, I think we write it as D and E. Does not exist, okay? Because On the left and the right side, they are not approaching the same value. The limit does not exist. Okay, that's kind of how that works. Okay, now in a similar way, this guy right here. Okay, I have a vertical asymptote at this guy. This is what I'm evaluating. The limit as x goes to 0 of 1 over x squared. If I try to plug 0 in, I would be left with 1 over 0 squared, which is still 1 over 0, and I cannot do that. No. Okay? The graph of 1 over x squared looks like this, so we're going to analyze the graph instead. Okay? So coming in from the right side, as I'm getting closer and closer to an x coordinate of 0, what's the y coordinate going toward?
It's getting larger.
It's getting larger, so it's kind of going toward positive infinity, right? On the left side, as I'm going towards 0, the y coordinate is going toward positive infinity as well.
Crazy.
Okay?
Well, it's like
So,
it's like it's infinity.
when I say the limit as x goes to 0 of 1 over x squared, that limit is technically infinity, but since infinity does not exist, on both sides, it's approaching infinity. It's approaching the same thing from both sides, but since infinity is not an actual number, this limit does not exist as well, right? Because infinity is not a physical number. So even though on the left and the right-hand side it's doing the same thing as it gets toward that 0, the limit still does not exist, okay? So if I give this to you as a test question, I will probably accept both answers, infinity and does not exist, because technically infinity is not a number, so it doesn't exist, but both of those sides are going toward infinity, okay? So let me do one more example. I'm going to make this example up, and I'm going to do this over here. Let's say the limit as x goes towards 0 of 1 over x, okay? So put that on your graph or on your notes over on the right-hand side. 1 over x. Do you know what 1 over x looks like if you graph it?
Just like a, yeah.
He's a boomerang. He goes this way, and he goes this way, okay? So x equals 0 would be this spot right here. X equals 0 is along that vertical asymptote right there. That's what x equals 0 looks like, that vertical asymptote there. So coming in on the right side, what's he approaching? He's approaching infinity from the right. What's he approaching on the left?
Negative.
He's approaching negative infinity. So what's the answer?
Not exist.
Still does not exist. Would I accept one of those answers?
Yes.
Like infinity or negative infinity?
Yes.
In this case, no, because they're approaching two different ones, right? One of them's negative infinity, one of them's positive infinity. So technically they're still not approaching the same number. So this one is only it does not exist. Does that make sense? Yeah, they're not approaching the same thing. So this one, because they were both doing the volcano thing, they're both going up there, both on both sides it's approaching infinity. So the limit could be infinity, or you just say does not exist, because technically infinity does not is not a physical number, so it does not exist, right? Okay. But over here, since it's approaching two different ones, approaching two different ones, negative infinity and positive infinity, those are going opposite directions, so those are really does not exist. This is the only answer that would be acceptable in that case. Okay? All right, good? All right, let's go to this one. Find the limit. Number 5, 4x plus 7. If I am graphing this thing, this is like y equals 4x plus 7. What does that look like?
It crosses over at 7, positive 7, and...
But what does this thing look like if you graph it? It's a line. 4x plus 7 is a linear function.
I was literally like mapping it out for you.
Right? Goes at 7. Okay, and then up 4 over 1, up 4 over 1, and it's doing this, right? That's what my linear function looks like. Okay? So I want to know at negative 1. At an x-coordinate of negative 1, what's he doing on the graph? What's he approaching for the y? Okay? Now, this is where it gets kind of like stupid almost, because it's like there's not even a hole there. So why am I evaluating at negative 1 when there's not even a hole there, right? When there's not even a hole there, I might as well just plug negative 1 into the dang equation, right? There's not a hole, I can plug it in, right? There's no undefined, no division by 0. So 4 times negative 1 plus 7 is 3. On the left side and on the right side, is he approaching a y coordinate of 3?
Yeah.
Yes. So when you can plug it in, when you do not have any problems, just plug the darn thing in. You don't even have to look at the graph. Okay, this next one down here, the square root of 2x. Okay, I am trying to find where he approaches 8. So the square root of 2x looks like this, something of that nature, right? He's a square root, something like that. Now, at 8, 1, 2, 3, 4, 5, 6, 7, 8, I want to know what he's approaching. There's not even a hole there.
4.
There's not even a hole there. So I plug 8 in. And 2 times 8 is 16. The square root of 16. Holly's been saying the whole time. Lacey, I'm calling everybody Lacey now.
That's me!
Lacey, if you're confused, Brooklyn got called Lacey today in the library. So she's been going around the whole day saying that she's Lacey. So they're not making fun of you or anything. She's just like, whatever. Anyway. All right, so 4 on the left side and the right side. Is this approaching a y coordinate to 4?
Yeah!
Is that y coordinate 4? On the left side and the right side, it's approaching 4.
She looks like
Yes. So, moral of the story, if you're trying to look for a limit and you can plug it in, always plug it in to start with, because that's where the limit exists, right? That's where the limit is at. Okay? Make sense?
Yes.
All right, beautiful. Would you like to watch the video?
Yes.
Yeah, let's watch it. Let's find
and
it.
I have
What
a
video?
question for help since I'll be
The
gone
mean girl
tomorrow.
video.
Also, how soon are you uploading the video for tomorrow?
8 a.m. Probably.
Can I have the notes because I'll be gone tomorrow?
Yeah.
Where are you going?
I have a job shadow with Dr. Bowen.
Yeah, whatever.
With who?
Dr. Bowen.
Oh.
He's not superior to me.
Oh.
I can't job shadow on these things.
Why?
Oh.
Who is your
Hood.
Who?
Hood. Yeah. Let me go over here. I bet this is going to be a better place.
How long will you have to use those things?
I don't know. Let's see. Mean Girls.
You're cringe, Fidel.
See if I can find it. Which one do I want? They're probably this one.
That one.
All of them.
Contestants, find the limit of this equation.
Calling somebody else
Right there.
fat won't
Is
make
it?
them
Right there.
skinny.
Not an equation.
Someone
Which is
stupid
sine and
doesn't
cosine,
make
which we
them
don't know how to do
sad.
yet. But
And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you.
the limit is -1.
Oh crap, I lost.
That answer is incorrect. Now we are in a sudden death. If Miss Aaron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh, God, it was so cute. I could focus, Katie. What was on